+1 or in intermediate first year to study physics, you always come across problems which are difficult for you because of the reasons that you in the school level has not properly covered the syllabus. That is number one, because the concepts are not clear to you at the fundamental level. In intermediate, what we do is we build up on those fundamentals and we assume that you know all those fundamentals. Because of that reason, there will be a gap for the students to attack problems. So, if you want to get good marks in physics, you remember, I will tell you a few tips. First of all, be thorough with the theoretical part. That means be sound in concept. In any chapter, try to be very good in concept. You give maximum effort to get the concept right. Afterwards, try to understand what are the relations that are coming out of that particular concept or that particular chapter. Try to understand the relations or formulae that are coming out of or framing out of that particular content. Once you formulated these things, now the part of exercise will come. You randomly choose any paper or any book in that particular chapter and try to work out problems without looking at the solutions. In the first round, suppose if you are attempting to do 50 problems, in the first round you may get 20 or 15 or 10, but don't get discouraged. Normal, it is always possible to be like that. Now, one by one you start doing whichever is difficult, you leave and complete the chapter, complete the exercise, and then come back to the unsolved questions again. When you are repeating this kind of process 2 or 3 times, automatically, intuitively, your standard in that chapter will improve, your knowledge in that chapter will improve, your skill in that chapter will improve. In the second attempt, you will be able to do somewhat more problems, and like that in 3 or 4 attempts, you will almost be able to complete. 90% of the problems will be over. There may be 10% which are a little bit hard for you at that level. You leave them, and afterwards, after 1 or 2 days, if you start again, most likely you will get them also. So, this is the way you have to prepare for any chapter, for that matter, any chapter. Once again, I am telling you, just go through the chapter theory part very successfully, very basically in the beginning, and afterwards formulate the relations that are likely to come from the theory part, and then apply those formulae or relations to do problems. And remember one thing, while doing a problem, try to do it in different ways also if possible. See, there may be number of solutions for a single problem. One may be short, one may be long. You have to do all sorts of methods possible. Of course, I know that current time will be a constraint, but at the same time, that will be, instead of doing 2 or 3 problems, even if you do one problem 2 or 3 ways, that is also same thing, same benefit you will get. So, like that you keep doing chapter by chapter. I will be advising you, I will be teaching you basic theory, and afterwards I will show you how to solve some standard problems, and afterwards you have to work out at your leisure time, at your study time to climb up on the class that we have completed. So, this way definitely you will score good marks in physics. Whether it is EAMCET, NEET or any other exam, basically these things should be applied. Read the theory properly, formulate the formulae from the theory and apply them to do the exercises. After doing 2 or 3 times also, if you are not getting any particular problem, you can contact us or you can contact me at any leisure time or at any prior appointed time. We can discuss that. Now, let us come to the curriculum part. As usual, we will start with mechanics, because mechanics is the first part in first year also, and it is the most interesting part for students and teachers also. That is why let us start with that, and one by one we will complete according to the schedule. in our discussions, first topic that we are going to discuss is units and dimensions. This is the first topic that we are going to discuss today. I will briefly give you the theory part, and then I will explain how to do some problems based on the basics that we discuss, and you can work out further based on this. In physics, there are numerous physical quantities we come across in everyday life also: mass, length, time, temperature, velocity, acceleration, speed, etc. There are so many physical quantities that we come across in physics. Somehow we have to classify them to study them in a proper manner. So the classification is made as total physical quantities are classified into fundamental and derived. All physical quantities can be classified as fundamental and derived. See, fundamental physical quantity means it is independent of any other quantity. Its existence does not depend on any other physical quantity. For example, length, mass, temperature, etc. These quantities does not depend on any other quantity. Length does not depend on mass or time or anything. It has its own identity. Similarly, mass, temperature, etc. Whereas derived quantities means these derived quantities are framed out of the fundamental quantities. Any derived quantity is framed or made from the fundamental quantities. So they are dependent quantities. They are not independent. For example, if you take velocity, example here let us take velocity is equal to displacement by time. So here displacement is actually length, time is okay, it is another physical quantity. So velocity depends on length and time. So it is a derived quantity. Similarly, acceleration. Acceleration is depending on velocity and time. Force depends on mass and acceleration. Like that, there are countless number of derived quantities. Fundamental quantities are limited. Derived quantities can be derived out of so many permutations and combinations. That's why we have numerous derived quantities. Now, the units that are used to measure fundamental quantities are called fundamental units, and the units that are used to measure derived quantities are called derived units. These are fundamental units that are used to measure fundamental quantities, and the units used to measure derived quantities are called derived units. Now, regarding the measurements either in fundamental or derived, we are taking some units. As I told you, fundamental units or derived units. But what system should be adopted to select these units? Suppose if you want to measure length. Now you are generally measuring length in meters, centimeters, etc. But as the subject developed in the early stages, they don't have that much of idea. So they started in different areas of the world, different convenient measurements of units were selected. Basically, there were three systems of measurements adopted throughout the world. The three measurements are MKS, and CGS and FPS. These are the three systems of measurements used to measure either fundamental quantities or derived quantities. MKS system means length is measured in meter, mass is measured in kilograms, time is measured in seconds. Similarly, in CGS, centimeter, gram second, foot pound second. So these are the three systems that are familiar throughout the world. There may be some other which are not known to us. These are the familiar systems used by people earlier. But because of different systems, there was a problem of transaction. If people following different systems are to transact, they have to have a common system. Out of this urge, a new system was emerged. Around 1962 or something, a new system was emerged and agreed by all the world, which is called International System or SI system. So this is the system which is adopted nowadays throughout the world, and particularly in all standard exams also, units are supposed to be given in SI system now. As a matter of observed rule, SI system is practiced everywhere. So in SI system, they first defined fundamental quantities. How many fundamental quantities are there and what are their units? They have given these are the fundamental quantities, these are the units, and based on that we can get derived units, and we can give some units in the name of scientists also. Those things also come under SI system. For example, if you take fundamental quantities in SI system, there are totally 7 fundamental quantities are there. There are 7 fundamental quantities. Number 1 length, number 2 mass, number 3 time, number 4 temperature, number 5 electric current, number 6 luminous intensity, number 7 quantity of matter. So these are the 7 fundamental quantities identified in the latest international system, and each one was given a unit. Length was given meter, mass kilogram, time second, and temperature Kelvin, electric current ampere, or this is also indicated as I. The symbol I is also indicating electric current. Luminous intensity candela, quantity of matter mole. So these are the fundamental quantities, these are the fundamental units in the SI system. Derived quantities are based on all these 7 quantities only, and derived units means units that can be derived from these things. Actually in SI system, sometimes what happens is, suppose if you take force, force is equal to mass into acceleration, mass times acceleration, force is equal to mass into acceleration. So here mass is kg, acceleration is meter per second square. This can be the derived unit for force in SI system. It is correct, nothing wrong in this. But you also know that force is measured in Newton. Because this unit is also replaced by a scientist name in honor of the scientist. So 1 Newton is SI unit. This is also equivalent to SI unit. Normally it is called MKS unit because all the things are in MKS system. But there is nothing wrong if you call it SI unit also. But more popular one is this one. Similarly, pressure. Pressure is equal to force by area. Force is again kg meter per second square by area means meter square. That means kg per meter per second square will be the unit of pressure, but in honor of Pascal, that is also called Pascal. This kg per meter per second square is also known as Pascal. So Pascal is the familiar SI unit. But all units are not given in terms of scientists. Suppose if you take velocity, velocity is equal to displacement by time. Its unit is still meter per second. In SI system also meter per second, in MKS system also meter per second. So all derived quantities are not given in honor of scientists. Sometimes in future they may give this is equal to Einstein. There is nothing wrong, then we will follow that. Now it appears to be awkward. Now we call that velocity. If a body is moving with a velocity 10 Einstein or something, if you say now, it may look awkward, but all derived units in honor of scientists are given like that only. Watt in honor of James Watt, etc. Now, after discussing briefly about units, let us go for dimensions. Dimensional formulae and dimensions. Dimensional formulae means if you express a physical quantity in the dimensions of in the fundamental quantities, then that expression is called the dimensional formula. If you express a derived quantity or some physical quantity in terms of fundamental quantities, that expression is called dimensional formula. In the basic fundamental quantities, you have to define, you have to express a derived quantity. For example, velocity. Velocity is equal to displacement by time. Displacement is L because it is length, time is t. So this will be equal to Lt power minus 1. So this is the dimensional formula for velocity. We have expressed velocity in terms of fundamental quantities. So it is an expression in which fundamental quantities are raised to the given powers for the required powers. Dimensional formula is an expression in which fundamental quantities are raised to the required powers. These powers to the units are called dimensions. Dimension of time is minus 1, dimension of length is 1. The powers of the fundamental quantities are called dimensions. So dimensional formula is the expression in which the fundamental quantities are raised to get a derived quantity. That is called the dimensional formula, and the powers to which these fundamental quantities are raised are called dimensions. Similarly, if you take force, force is equal to mass into acceleration. Mass into acceleration. Mass is m fundamentally, acceleration is length by t square. MLT power minus 2. MLT power minus 2 is the dimensional formula of force. Dimensions of mass in this is 1, length is 1, time is minus 2. So this is how we can write a dimensional formula. If you know a physical relation for any physical quantity, you can write the dimensional formula. Remember here, to write a dimensional formula, basically you require an expression for that quantity. If you want to write dimensional formula of force, you should know the formula for force, F is equal to ma. Otherwise you cannot write. Suppose if you want dimensional formula of pressure, dimensional formula of pressure is, first you should express that in terms of some known formula, force by area. Force by area is the formula which we know. From that we can develop the dimensional formula. Force already we derived, mLT power minus 2, area is L square. So it will be equal to ml power minus 1, T power minus 2. This is the dimensional formula of pressure. So like that you can write dimensional formula for any number of quantities. Only thing required is for each one you should know the expression, physical expression. You can go on writing dimensional formula for any physical quantity, Suppose angular momentum. angular momentum is nothing but product of mass, velocity and radius. This is the relation which you will come across in rotatory motion, but while deriving dimensional formula, we should know some relation. Remember that not only one relation, there are so many relations for this. You can have angular momentum is equal to I omega. This also comes in rotatory motion. So like that, you have so many relations for a particular quantity, you can use any one of them. Mostly you can use convenient one. And the one for which you know the dimensional formula at hand. So if you use this one, MVR, M is equal to mass, velocity is Lt power minus 1, radius is again length. So you will get ml square T power minus 1. Suppose if you want to use I omega, I is moment of inertia, omega is angular velocity. Omega is angular velocity means I is, let us write the expression I is kg meter square, ml square. Dimensional formula for moment of inertia is ml square. Omega is radian per seconds. Radian per second means radian has no dimension, so only we have 1 by t. So that is equal to ml square t power minus 1. So the dimensional formula we derived using different methods, means different relations for the same quantity. You can do like that. Always you choose the easiest one to derive the dimensional formula. Suppose if you want to derive dimensional formula for magnetic induction. In magnetism, we come across magnetic induction. If you are asked to find what is the dimensional formula for magnetic induction, first you should get some formula relating to magnetic induction. Which one is better? We know the formula F is equal to BIL. In electromagnetism, we know the formula F is equal to BIL. F is force, B is magnetic induction, I is current, L is length. So B is equal to F by IL. Dimensional formula for current is I or A. You can use A or I. There is no difference. Length is L. Force is MLT power minus 2 by IL. So what we have is MT power minus 2, I power minus 1. Like that, we can derive dimensional formula for any physical quantity by writing easier formula. Suppose if you want to write dimensional formula for electrical capacity or capacitance. To write the dimensional formula for capacity, you should express that in terms of some known quantity. Capacity and charge are related by this relation. Q is equal to CV. And charge is equal to IT. We know that. Q is equal to IT. I is electric current, which is a fundamental quantity, and time is also fundamental quantity. So write IT is equal to CV. Again, V is volts, voltage. Voltage is also derived quantity. We should express that in fundamental. We know that W is equal to VQ. Work done is equal to VQ. So from that V is equal to W by Q. W is work is same as dimension of energy, which is ml square T power minus 2 by Q is IT. Now you can write IT is equal to C into ml square T power minus 2 by IT. You can simplify this and you can get the expression for capacity. Dimensional formula of capacity can be written. Like this, for any physical quantity, we can write dimensional formula. Only thing required is you should remember some relation or sometimes a pair of relations like this to get to the result. Now, what is the use of writing dimensions like this? Dimensional formulae we are trying to write for numerous quantities. What is the use of this dimensional formulae? There are so many uses. To be specific, number one, we can check the correctness of equations. We can check the equations. That means whether the given equation is correct or wrong, we can check it simply by applying dimensions. Generally, the concept behind this is always you have to equate similar quantities. You cannot say that my height is equal to 1.5 times your weight. That is always wrong. You can say that my height is 1.5 times your height or 1.5 times your height. My weight is 1.5 times your weight. Like that you can say, but you cannot equate different quantities. So that means both the quantities on either side of the is equal to sign should be same. That is the idea behind applying this. Therefore, dimensions on either side should be same. If the dimensions on either side are same, then we can say that the equation is correct. And one more thing is, you cannot add different quantities. There is no meaning if you say 2 centimeters plus 4 seconds is equal to something. You cannot add 2 centimeters and 4 seconds and 5 kg. So only you can add 2 seconds with another 2 seconds or 4 seconds. That means time can be added to time, mass can be added to mass, velocity can be added to velocity. That means velocity, that means any quantities, any physical quantities can be added only when they are same. Otherwise, there is no meaning at all. So that means if there is a plus sign or minus sign, that indicates only one quantity. So on the is equal to on either side of is equal to, you should have the same physical quantity. And moreover, on any side, if different quantities are added or subtracted, that means they must represent the same quantity. So based on this logic, we can check the correctness of any physical equation. For example, take the equation V is equal to U plus AT. V is velocity, U is also velocity, A is acceleration, T is time. So here velocity is equated to velocity plus AT. AT is what? AT means A is acceleration LT power minus 2 into time. So that is equal to LT power minus 1, which is dimension of velocity or velocity. So here LT power minus 1, here LT power minus 1 plus AT is also LT power minus 1. As I told you, when quantities are added, they represent the same thing. That means LT minus 1 plus LT minus 1 is not equal to 2LT minus 1. It is equal to LT minus 1. So dimensionally both are same. Then the equation is correct. This is the simplest way of checking. For example, we have another one. Sn is equal to U plus A into n minus half. Displacement in the nth second is equal to initial velocity plus acceleration into n minus half. So here displacement in the nth second is equal to velocity plus acceleration into time. Already I showed you acceleration into time, AT is equal to LT minus 1 only. So Sn is equal to velocity is LT power minus 1 plus A into, this is time only. So A into T is velocity LT power minus 1. So you are getting LT power minus 1 on the right hand side. On the left hand side, what is this? This is displacement in the nth second. So don't confuse displacement with displacement in a particular second. Displacement in a particular second always indicates velocity. So Sn here stands for velocity. Remember that. It is not representing displacement. So displacement in the nth second is nothing but velocity, which is having dimensions LT power minus 1, which is also equal to the right hand side. So automatically you can say that this equation is correct. So using this dimensional method, we can check the correctness of physical equations. Another advantage with this is Second advantage is to derive relations between various quantities or to derive physical relations based on some statements given, some proportionalities given. You can derive formulae. If you are given some statement, using that statement you can derive a relation or formulae. Of course, there are some handicaps in that, we will discuss that also, but basically how we derive relations based on statements. Let us see one example. Kinetic energy of a moving body is proportional to mass and also proportional to velocity. You are given a statement like this: kinetic energy of a moving body is proportional to mass and velocity of the body. If you are given a statement like this, you are asked to derive a relation for kinetic energy, and you are given proportionality constant is equal to half. If you are given proportionality constant is equal to half, and if you are asked to find the relation for kinetic energy, given the statement kinetic energy is depending on mass and velocity. So what you have to find is how it depends on. Ke is proportional to m square or m cube or m, or Ke is proportional to v square or v cube or v or root v, etc. So finding that only we can do using the dimensional relations. For example, see here, kinetic energy is proportional to mass power A, velocity power B. We know that it depends on these two quantities only. Let the dimensions in the dimensional relations for kinetic energy be for mass A, for velocity B. Now kinetic energy is energy. Energy has dimensions of work, which is ml square t power minus 2. If you have any doubt regarding this, you should go to the fundamental. See, always there is a possibility for going wrong. Energy is nothing but work. Energy is equal to work. Work is equal to force into displacement. So force into displacement means ml t power minus 2 into L. ml square t power minus 2. So like that, anyone, if you have doubt, you can go for the basics and derive. So ml square t power minus 2 proportional to mass is a fundamental quantity, m power A. Velocity means its dimensional formula is Lt power minus 1 whole power B. Now this is proportional to m power A, L power B, T power minus B. Now equate the powers of similar quantities on either side. So here mass power on the left hand side is 1, on the right hand side is A. So A is equal to 1. Similarly, length power on the right hand side is B, on the left hand side is 2. So B is equal to 2. So we need that only. We need not again take power of time, because that will also give the same answer. Minus B is equal to minus 2 means again you will get to B is equal to 2. So A equal to 1, B equal to 2. So what is the relation we are getting here? Ke proportional to mv square. M power 1 can be written as m only, mv square. Proportionality constant is given as half. So Ke is equal to half mv square. That is the relation we are deriving from the statement given. So like this, if any statement is given, we can derive the expression for it. Another thing is, third thing is converting one system of units into another system. converting one system of units into another system using the same dimensional method. Here what we will do is, suppose if you want to convert to Newton into dynes, unit of force in SI system or MKS system is Newton, in CGS system is dyne. So let us try to convert to Newton into dyne, converting one system of units into another system. For that purpose, first this Newton or dyne is representing which quantity? First you should question like that. Force. Force. What is the dimensional formula of force? MLT power minus 2. Now 1 Newton is equal to 1 kg meter per second square. 1 Newton is equal to 1 kg meter per second square. Similarly, 1 dyne is equal to, dyne means CGS system, no? So gram centimeter per second square, because in CGS we use for mass gram instead of kg, for length centimeter instead of meter, second is same. So this is the dyne value, this is Newton value. Now our aim is to convert Newton into dynes. So what we should do is, 1 Newton is equal to this let us try to convert into this. 1 kg is equal to 1000 grams into 1 meter is equal to 1000 centimeters, 100 centimeters, beg your pardon, 1000 grams into 100 centimeters by second square. 1 kg meter per second square is equal to 1000 gram 100 centimeter per second square, that is equal to 10 power 5 gram centimeter second square, which is nothing but dyne. So this is equal to 10 power 5 dynes. That means 1 Newton is equal to 10 power 5 dynes. See, 1 Newton is nothing but kg meter per second square. 1 dyne is equal to gram centimeter per second square. Now convert this into grams, this into centimeters, and write like this, 10 power 5 gram centimeter per second square. So 1 Newton is equal to 10 power 5 gram centimeter per second square. Now gram centimeter per second square is equal to dyne, so substitute it here. That means 1 Newton is equal to 10 power 5 dynes. That means we have converted Newton into dynes. Now this is the third method of applying dimensions for physics. Now let us try to do a few problems based on the theory that we have discussed so far. Let us see the first one. First one, let us read. If the unit of force is 2 newtons, that of length is 4 meters, and that of velocity is 6 meters per second, unit of mass is how much? See, unit of force is given to you, 2 newtons. Unit of length is given to you as 4 meters, and unit of velocity is given to you as 6 meters per second. Now what is asked is unit of mass. See, force is equal to 2 newtons, length is equal to 4, v is equal to 6 now, velocity is equal to length by time. Velocity is equal to length by time. So time is equal to, time will be equal to length by velocity. Time is equal to length by velocity. Length is 4, velocity is 6, so that will be 2 by 3. So time unit is 2 by 3 in the given system. Now acceleration is equal to length by time square. because meter per second square no length by time square. Length is 4, time square is 2 by 3 whole square, 4 by 9. So acceleration is 9. Now what is force? Force is equal to mass into acceleration. Now what we want is mass. Mass is equal to force by acceleration. Force is 2 newtons, acceleration is 9, so 2 by 9. So the unit of mass in the system given in the question is 2 by 9 kg. So the answer will be first one. This is the question based on units in one system to another system. You can simply do like this. You have to use the relations and finally get the quantity that is required. Next one. See here in this problem, in this question, velocity is given, velocity is equal to a by b into 1 minus e power minus bt. Actually, if there is some error in the question, you can correct it like this: a by b into 1 minus e power minus bt. Now, what you are asked to find is dimensional formula of a is what? It will be same as what? See here, v is equal to a by b minus a by b into e power minus bt. You can write like this. As I already told you, on either side of the is equal to sign, quantity should be same. Here if it is velocity means this must be velocity, this must be velocity, because they are subtracted from one another. Addition and subtraction should give the same quantities, no? So this is velocity, but exponential and trigonometric and logarithmic functions doesn't have dimensions. Remember that, note down this point. Exponential, trigonometric and logarithmic functions doesn't have dimensions. That means as a whole it has no dimensions. That means this is dimensionless. So this is dimensionless means bt should be dimensionless, means b should have the dimension of time inverse, because bt is equal to m0, l0, t0 means b should be equal to 1 by t, t power minus 1. So dimensional formula from the given expression for b comes out to be t power minus 1. And one more thing is velocity is equal to a by b. Velocity is equal to a by b, we know that. So a is equal to velocity is lt power minus 1, b is time, 1 by t, sorry. B is 1 by t or t power minus 1, that is equal to lt power minus 2, which is nothing but acceleration. Acceleration. So here A stands for acceleration. Second option is correct. Next one. Next one, let us see. So in this you are given two systems of measurements and the units in the two systems are given in the ratio 2:3. Read the question. If the units of two systems of measurements are in the ratio 2:3, the ratio of units of angular momentum in those two systems is. For this type of question, for the ratio, what you should do is write the dimensional formula of the quantity involved in the question. The quantity involved is angular momentum. Angular momentum is equal to ml square t power minus 1. As I told you, if you have doubt, you derive it. Actually, after derivation you can work out, because it won't take more than 15-20 seconds. So ml square t power minus 1 is written like this. So that is equal to m1 by m2 into L1 by L2 whole square into T1 by T2 whole power minus 1. So like this, if you take the ratios are given for all units, the ratios are given 2:3. M1 by M2 is 2 by 3, L1 by L2 is 2 by 3, but square is there. T1 by T2 is 2 by 3, but whole power minus 1 is there. So this is 2 by 3 into 2 by 3 whole square into 1 by 2 by 3. So it will be 4 by 9. Actually 4 by 9 is correct, fourth option is correct. May be wrongly mentioned, fourth option is correct for that. Next one now, next one. If the unit of mass is 1 kg and unit of length is 1 meter and the unit of time is 1 minute, then the unit of pressure. So pressure again, pressure is equal to force by area. Force is mLT power minus 2, area is L square, that is mL power minus 1 T power minus 2. Now what we have to do is mass is in the new system is also 1 kg. In the new system length is 1 meter whole power minus 1 and time is 1 minute. 1 minute means 60 seconds whole power minus 2. So we know that 1 Pascal is equal to kg per meter per second square. Kg per meter per second square, we know that. Now here this will be equal to kg per meter into 1 by 3600 into 1 by second square. Exactly, if you write this like this, it will be equal to 1 by 3600 kg per meter per second square, which is nothing but Pascal. So this is equal to 1 by 3600 Pascal or 1 by 3600 Newton per meter square. So the answer will be third one. Okay, like this we can now continue doing, but remember one thing, as I told you in the beginning itself, go through the fundamentals and try to apply them, formulate for important relations, try to apply them to do problems. It is the easiest thing to do to get marks in physics. Thank you.